This question's asking you to identify which of these compounds has a chiral center in the R configuration. And we're just going to go assign R and S according to the Conning-Ingold Prelog rules here. Each of these has one chiral center, and we're just going to go through and assign R and S here. So priority goes to the highest atomic number for the 4 atoms attached. This guy's attached to 3 carbons and a sulfur. Sulfur is definitely number 1. Between the other 3 carbons, this one's bonded to 3 H's. This one here is bonded to a carbon out here and 2 H's. And then this one's got 3 bonds to oxygens. So the first point of difference, this guy's going to get to be number 2. And then carbon's going to beat hydrogen here, so that's number 3. And this methyl group's going to be number 4. So in this case, we have a problem. When your lowest priority group is the dash, that's exactly how you should have assigned it. When it's a wedge, it's opposite of how you should have assigned it. And it turns out to be opposite of the way it looks from your perspective. But when it's in the plane, we have a little bit of an issue here. And so I'm going to redraw this one here. Keep the 2 bonds in the plane, the wedge and the dash all in the same place. What I'm going to do is switch this guy in the dash. So here I'm going to have the ethyl, keep the SH on the wedge, and I'll keep the carboxylic acid. So, but then I'll put the methyl in the back so I can assign it as it is. He's still number 1, he's still number 2, he's number 3. And as I go around the circle, 1, 2, 3, this guy is indeed R. But when you have 2 groups trade place on any stereocenter, you actually get the other stereoisomer. And so even though when I switch these as R, it means the original must have been S. So any answer with 1 in it is going to be wrong because it is not in the R configuration. Between the last 2 choices, I can see it's either 2 or 2 and 3. So 2 is definitely going to be in the R, as we'll find out. So let's just assign 3 to get cut to the chase here. Here we've got a Fisher projection. Your horizontal bonds are wedges. Your vertical bonds are dashes in a Fisher projection. And in this case, oxygen definitely has the highest atomic number of the 4 atoms attached. Then between these 2 carbons, this one's got 2 bonds to oxygen and a hydrogen. This one's got 1 bond to oxygen, carbon. So 2 bonds to oxygen is going to win. That's going to be number 2. He's number 3. The hydrogen's number 4. And in this case, as we go around 1 to 2 to 3, looks like a left-handed turn, which would normally correspond with S. But in this case, with the hydrogen on the horizontal, which is a wedge, so it's exactly opposite of where it should be in the dash position. And so even though it looks like it's S from our perspective, it's really the opposite when your lowest priority group is in the wedged position. So it's R. And finally, this last one here, he's bonded to 3 different carbons, and then not drawn in is a hydrogen in the dash. So at least our lowest priority group is definitely the hydrogen. Between these 3 carbons, though, this carbon's got 2 bonds to a carbon. So we count that as twice as carbons, and then a hydrogen. So this one here's just got 3 bonds to carbon, so just be carbon, carbon, carbon. And then this one's bonded to 1 additional carbon and 2 hydrogens. Carbon, hydrogen, hydrogen. So we can see the first point of difference here. This guy's going to get to be number 1. Next point of difference, this guy's going to get to be number 2, and then number 3. And as we go around 1 to 2 to 3, it's a right-handed turn or clockwise. The lowest priority group is in the back, and so that corresponds to R as normal. And again, 2 and 3 both correspond to the R configuration.